Hello, good evening, good morning, or good afternoon, depending on where you are. My name.
You
Stop
threatened you
laughing.
threatened to talk like this all the way through, didn't you,
Stop
Jamie?
laughing. This is real. This is good. In.
Okay.
This is the Cloud Native Attitude, starring Jamie Dobson and Ian Mile. Say hello, Ian.
Hello.
Why am I doing this funny voice?
Don't
I'll tell
know.
you why I'm doing the funny voice because the feedback we get is the more the dafter we are, and the more well, silly the right word, the more people seem to enjoy the podcast. So I'm committed to being dafter than ever.
Well, you don't have to commit to being daft, Jamie. You are daft.
No, dafter.
Or dafter.
Right, I'm committed to being even dafter just for the sake of the audience. And in these days of artificial intelligence and artificial stupidity, uh, a bit of human daftness, I think, is what is required.
Well, we can't be completely daft, Jamie, because we need to have some insights and
Oh. Yeah, you're in trouble though, Ian. You're in trouble because today's episode, listeners or viewers of the YouTube channel, today's episode is where to start the myth. No, I've said that wrong. Oh my God. Where to start the mythical blank slate. And the mythical blank slate is really, it's just that, it's mythical. And actually, if
hmm.
people think there's a blank slate, it's because they're pretty daft. So to
What are we
counter this
talking about
daft
with blanks? What do you mean by blank slate, Jamie?
the blank slate, well, I was going to come to that, but basically what we mean by the blank slate is the idea that whatever you've inherited, whether it's legacy, it runs on Linux, it has COBOL backend somewhere. If we could just get rid of it, if we could get rid of it all and start again, we would build the perfect system. But we wouldn't build that nonsense, and this perfect system, well, would be perfect because we're not as daft as the people who built that old thing because we've learned and we've got new techniques and we've got new tools. That is the mythical blank slate. And with that in mind, Ian, we're going to talk about a few things. The first thing we're going to talk about is exactly that. Why is it mythical? And based on that, we're then going to talk about what happens when we build large systems and where does the value really lie. And then third and finally, we have two thought experiments. These appear in, I think it's chapter 6 of the book. Let me just check, page 54. And these thought experiments are designed to help people, managers, leaders, engineers, make the right decisions when it comes to their cloud native stack.
Okay.
Does that make sense to you?
It does. I'm thinking about things we need to talk about already.
You think about that, and I will fill the with a dad joke. I
Go
don't
on then.
actually know any dad jokes, but I did. Okay, here's a dad joke. Oh no, wait a minute. That might be no, wait a minute. That might not be appropriate. Okay, fine. Let's get on with it. So the mythical blank slates. First of all, have you ever done it, Ian? Have you ever said to yourself, right, we're going to do this from scratch?
Yeah, yeah.
And
In
when
my
you did it from
20s.
scratch, was it better than what we had previously?
Uh, in some ways it was, but it very quick you very quickly get a different. You know that saying, every happy family is alike, every unhappy family.
Tolstoy. We're straight into Tolstoy.
Yeah, I think I may have referenced it before, but I talk about it a lot with customers because every customer we talk to is like an unhappy family, and they're
So
all.
what you're saying is every happy customer is similar to our other happy customers, but every miserable customer is miserable in their own unique way.
Yeah, if a business is functioning well, it all looks the same. Everyone is busy, everyone is productive, everyone is happy. Uh, you know, that's a good, well functioning business. But the unhappy ones they're all unique in their unhappiness. They're all
What's
unique in their
that got?
difficulties.
And what's that got to do with?
Well, what I was thinking was that when I have built from scratch, I've started off not making the mistakes I've seen before, but making a whole new class of mistakes that I hadn't foreseen.
Now, but that happens when you build on top of your own stuff. So I developed these techniques. I called it free coding. And free coding is based on free writing. So when some writers wake up in the morning before they've had the coffee, when the subconsciousness is bubbling, and they just write. They write with reckless abandonment. Stephen King calls this writing with the door closed, right? Just pretend nobody's watching. Anyway, so I had this idea. What if I free coded? What if I just typed what was ever in my mind, didn't bother too much about naming conventions, etc., etc.
Right.
What would come out? Anyway, so then that technique developed into this. Let's say I had a problem. It had to be a unique problem. If I'd done it before, who cares? So let's say
Mm.
I had a unique problem. On day one, I would free code and then I would throw it all away. I wouldn't look at it ever again. On day two, I would use test driven development to evolve or iterate my way to the solution.
Right.
And then I would throw that away. And then on the third day, I would do it properly. And I actually got to a point where I was like, I need to measure, is my third day solution better than, for example, if I'd have just started doing it properly from the beginning? But I wanted to sort of diverge my thinking to try to land on a solution that I thought was, the best one.
So there's an analogy there with writing, isn't there? Because well, you've made it yourself, but I know that whenever I've written something and then lost, in the old days when you'd lose an essay because it was written down on a piece of paper that you'd lost, and you had to write it.
Right.
You had to rewrite it the day before. You'd often find that it was much, much better than it was
It was
before.
much better, and herein lies the rub. This is the problem. Doing a blank slate on yourself is okay if you do it quickly because you've remembered the lessons.
Mhm.
The problem is that any system, whether it's this computer that we're both looking at, the microphone in front of me, even this pen, lots of mistakes in systems development happen. We learn a lesson in that particular moment in time. We fix it. The system becomes better. And importantly, the components of the systems interact with each other. But the new person, the new girl, the new guy, do not know what those mistakes were. All they see is the final artifact. And so they start to think, well, actually, if I can get rid of that and start again, but then you are throwing the baby out with the bathwater because there's values in those lessons.
Well, you mentioned COBOL earlier, and why are we still using COBOL in 2025? I forgot what year it was then. Why are we still using COBOL in 2025? Because so much logic is embedded in that COBOL that we don't understand. It's archaeological now.
No, it's archaeological, but we know it's valuable.
Yeah.
We know it's valuable. It's the same like we might not understand why the banks of a river are flooded, and then we build houses on them, and then the houses flood. Yeah,
Mm.
because if you build on floodplains, that's what happens. So you might not fully understand how something works, but there's often a reason for them. So this idea, and this is the other thing I like to remind people of. People almost hate legacy systems. I think that's weird, right? I think that's really weird. They usually generate nearly all your revenue and therefore pay your wages and create an environment that's safe enough for you to moan about them in.
We've had more than one customer come to us and say, we've got to rewrite our central system into a new language because it's 30, 40 years old or whatever. And we do the sums and we're like, well, that's going to cost you, don't know, God knows how many millions and more, probably. It's unestimable how much that will cost. And you know that you can keep that old system running by paying someone very well, paying 2 or 3 people very well for the next 20 years to just curate it, make sure it ticks along nicely. Which would you rather do?
The other weird thing is if the legacy systems don't change, so there's not much debugging to be done because all the bugs have been ironed out, and actually you're not building features in the legacy, you're building them on top of it. What's the point? What's the point of rewriting something?
Well, I guess that's the counter argument is, does that stop your innovation? If
Right.
you've got this system that can't be changed or is too complicated to change.
It's funny because Chris Swan just this second, well, just this few minutes ago, sent me something on LinkedIn. He talked about it being like Jenga. The reason you don't touch the legacy system is not necessarily because it's good or powerful, but that it's all the stack is built on top of it, and it's like the end of a Jenga game. It's not the beginning of a Jenga game when you've got quite a nice, neat, stable block. You're up this high, and so people become very scared of changing the bottom of the stack because it might topple the top of the stack. I thought that was quite a good analogy, really, from him.
Yeah, I think that's a very good. It's a very good analogy, and like, well, I was thinking like it's like a architectural post. It gradually sinks into the ground, and then becomes harder to move.
So I think that, so legacy systems have got a lot of value in them. Legacy systems can be risky to change, and sometimes the risk and the reward don't what's the word? They don't match. It's like the risk is way too high for the potential reward you're going to get. But I do think it's fair to say that this idea that if we start from scratch, we'll do it all right is incorrect. And I would say there's probably 3 reasons for that. The first one is you're discounting the lessons the previous system builders learned. You will learn the same lessons, you will make the same mistakes. And therefore, you might have very similar dirty hacks because you and your team, just like them and their team, will be up against time pressures, cost pressures, and all of that.
I think there's another factor here, which you may be coming onto, but I think is really important to call out, is your original system was probably built by a small group of dedicated people whose jobs depended on them making something that worked. That's how most businesses start. And that's why how most of these complicated subsystems begin, to use the team topology language. Um, but if you're a company now of 100 engineers and you say, hey, everybody, we're going to rewrite from scratch, suddenly you've got 100, potentially 100 voices all saying, my spacing is the right spacing for these files. And then you've got another engineer who says the opposite. And then you've got another engineer who says, we should be using this library. And so it goes, and it goes on and on and on. And you end up in a situation where you can't get anything done. So I think replicating that original crucible of things that got the original work done, however messy, however much technical debt you might think was in there, is it reproducing that with a large group of people is it's nigh on impossible
I mean, every
without
time,
some.
whenever I worked in a large business, I'd come into teams with 40 people in, and I'd just get rid of,
Yeah.
32 of them immediately because the communication overhead of coordination, and that's just this mythical man bullshit again. Like, oh, the more people we put on this, there's a linear relationship between the number of people on this project and the speed at which it's going to go. This is pure Victorian factory age fucking thinking. It doesn't work, and it's true. So that wasn't going to be one of my points, but I think you make a good point. Is that systems are developed by small teams, and
Actually,
then
I wonder if there is a Victorian factory analogy there, because if you've got 100 people spinning cloth in a spinning cotton in a Victorian factory, and you said we're going to build a new super duper factory that solves all the problems we've had before building this factory, which is a mess and
yeah,
everything's damp over here, whatever.
no,
Those 100 people would be terrible at it.
no, I don't. No, I'm not sure I agree. And there's two reasons why I don't agree. People spinning cotton, they know the job. So all manufacturers, if you need to fix your factory, speak to the people doing the actual work. That's what the Japanese taught us. Well, actually, Deming taught the Japanese that he learned from America, whatever. It's a convoluted story, that. And so if you said to, let's say you get a works committee of 10 weavers and a finisher and all of that, and say, look, listen, you know what the problems of the factory is now. If we designed a new factory, what problems would you iron out? How would you do things differently? How would you do the workstations? I think they would come up with a better factory.
So you hit on something really important there, which is I was making the assumption that the 100 people would go off to a field and start building a new factory. And that was my analogy for 100 engineers
Right.
building the new thing. What you've said is if the organizational structure is right and the discipline is there, they would do a better job. And I agree with that. But it's very hard when you're dealing with a blank slate. It's very hard to get that organizational structure right, because what is driving that organizational
Right.
structure to work right?
Now you've hit onto a good point, because that's exactly the myth of the blank slate. If we're going to do a factory from scratch, it's not a blank slate. You're taking all of your lessons with you because you're the people in the first factory and you're moving to the second. That's not what's happening in software. The small original team have retired and gone somewhere else, and a bunch of randoms, they might as well come from Mars. A bunch of aliens have come, like exactly like you said, like archaeologists trying to decipher this system and not fully understanding it, and therefore discounting some of the valuable things it does. I've now forgot my 3 points. See, what was my first point again?
I didn't write them down, Jamie.
No, my first point, what did I just say a minute ago before you mentioned the factory and the weavers?
Oh, I can't remember.
God, this is the middle-aged man
This
talking on the
shambles.
podcast again. So I think the other reason, what was I going to say? Oh my God, the mythical blank slate
There might be an
legacy.
edit. There might be an edit here for you, Jamie, to do.
Right. No, I'm not doing the editing. No, the people love to watch me struggle. Right. Anyway, yes, I remembered it. So the other thing is that your habits and your tools of the day, this is also a type of legacy. So it might not be code in a database, but if you go from scratch and you haven't actually updated your work habits, and we've seen this work before, we've seen this where, and we even talked about it on this podcast, a company grabs its best engineers, its quickest engineers, all of that, and they say, right, if we put them in a skunk works, if we put them in an office and change all the rules, they'll build something awesome. And yet they managed to replicate the same legacy that they were moaning about in the first place. And that's because those people, their thinking habits and their style of programming and all of that goes with them. So really, the myth of the blank slate is, on the one hand, well, you rely on your own thinking, and then on the other argument is, well, actually, by starting with the blank slate, you're throwing a lot of the value away simply because you don't understand that system.
Yes. So how? So I think what listeners might want to know is like, what do we do about it?
Well, so this is where, so this wasn't my idea. This is Anne's idea. This is from chapter 6. So she basically says, okay, right, don't forget the goal. So we're now going all the way back to episode 1. What's the goal, Ian?
Oh,
Of
don't
Cloud. Oh
don't
my
ask.
God. But okay, fucking hell, I'll do it. The goal of Cloud Native is scale, margin, and
You're reading it. You're reading it.
I'm not reading it. I've got the book in mind. I don't need to read it for that. I'll do it. I'll put the book down. Go on then. Ask me again.
What is it all for, Jamie?
Scale, speed, and margin. I haven't forgotten that. Scale, speed, and margin. And when we talk about speed, we usually mean feature velocity. So the time it takes to get a feature into somebody's hand, but also we also mean the ability to patch, roll forward, or roll back. You know, if we're doing chaos engineering and stuff like that. So the first thing that the book asks and that Anne asks is, well, don't forget your goal. So if you're after speed, scale, and margin, would a blank slate approach be the most appropriate one? I think in a lot of times the answer to that question is going to be
Well, it's very rarely going to be yes, isn't it?
it's very rarely going to be yes. And then to help our customers and our readers along, we ask them to conduct a thought experiment. And the thought experiment goes something like this: repackage your monolith, right? So I'm going to read from the book now because this is important. It goes something like this: imagine you're an enterprise with an existing monolith that requires minor tweaks and repositioning. That would suit you for a completely new market. Your immediate problem is to iteratively deliver this system. Scale is not an issue, and neither is margin. That's really important. So this is the first experiment. You've got a monolith. I don't know what your monolith would do. You sell, your EasyJet. You've got a monolith that sells aeroplane tickets, and you get a cockamamie idea. Oh, we could use a similar interface and some of the back end logic to sell cars, right? But you don't know if there's a market for easy rentals. So are you seriously going to blank slate that? Like a fucking lunatic? So, right, we're going to start from scratch. We're going to do some APIs and microservices, and we're going to build it so that we can scale up and scale down. And then you launch with a brand new advertisement in between Coronation Street or Baywatch on Saturday night. Hey, come to easycarrental.com, and nobody buys. So really, speed of features and especially scale in that case and margin don't count because you don't know what the demand will be. So this is the experiment Anna's asking the readers to go through. It sounds in that case, you're trying to work out if there's if there is a market for your product. Therefore, you don't need a blank slate, do you?
Right. So you're warning against building for a market that doesn't exist.
Well, the warning is if you don't need scale, margin, and velocity speed, then you don't really need cloud native for now. So blank slating it doesn't seem like a very good idea.
Yeah. So that's the flaw in thinking you get a lot from engineers, isn't it? Is I've got to
100%.
build this perfectly, in the optimum way, where optimum means millions of people are using it and it's super popular and everything. And actually, what you need is to build enough to see whether you need to go that far.
And this is a recurring theme. I remember 2 years ago, you and I were working with a customer, and there was a lot of talk about guardrails and security and container scanning and all kinds of stuff. And we were like, oh, this is great. Music to our ears. You've really done your homework. You're shifting left on security. You're shifting left on contract testing. Awesome. How many customers were talking about? Oh, we're not sure if anybody's going to buy this. And we were like, holy shit. You've got 10 architects in a room, good architects that probably should be working somewhere else. But you don't actually know if anybody's going to buy this system.
Yeah, because that's the way we do it here, right? That's what they were thinking. That's how we do it here. This is
How
how
we
we
do it
build.
here for the other product that does have hundreds of thousands
Yeah,
of users. So in a
yeah.
way, I suppose the book is asking people to slow down. So let me just paraphrase briefly, Ian. So we start off by saying, is this a scale, speed, and margin problem? If it's not, we're not going to blank slate it. If you've got a monolith, coming back to the EasyJet example, you've got something that works. The question simply becomes, or the options you've got are basically twofold. If you can, reskin it, stick a new front end on it, stick it in its own virtual machine, and work out if you've got a market, fandabidozi, we're away. However, the alternative would be to put on a web front end in this example and a couple of microservices and then present it to the market, but not a full blown cloud native system. Just a couple of services working out if the market's there.
So this is what I get. I often get annoyed when I hear people talking about technical debt because people talk about technical debt like it's an inherently bad thing. And to me, technical debt just means you made a compromise in the past. And whether that compromise was a good one or a bad one is very hard to tell at the time. I'm assuming you're making it for rational reasons, these trade-offs. But people act like, oh, well, we've incurred technical debt, so we did it wrong. It's like, no, uh, you didn't do it wrong. You did it right for the time, potentially. Maybe you did. Maybe it was a bad decision. I don't know. But all engineering requires trade-offs. You know, there are bridges that maybe they should have been made of granite, but that would have cost a fortune when you built it. You didn't know if anyone was going
Yeah.
to use the bridge.
Yeah.
There's all sorts of ways of doing this analogy, but I'm reminded of when we talked to Sam about microservices, and he said that uh, a fair chunk of the time he goes in and says, "Why don't you just have a bigger machine?
Yeah.
Just scale the
That's
machine
right.
up."
So I think, do you know, it's remarkable. I love it when people call themselves software engineers because I'm thinking you couldn't engineer your way out of a fucking paper bag, right? That's my first thought often. I mean, maybe that's a bit disrespectful, but if you were a software engineer, you'd understand constraints. And lots of programmers get very confused about constraints. So Jerry Weinberg, a very famous consultant, he's passed away a few years ago, but Jerry Weinberg was an absolute legend in the world of computing. And he just used to draw two axes on a whiteboard, A and B, called it a constraint graph. And he would just draw a line from the top of the graph to the bottom of the graph. So he was like, look, let's say it's money and it's been traded off against speed, or it's happiness traded off against, and he would basically simply force his customers to explicitly look at the trade-offs and then make them make a decision. And ultimately, it's because he was saying you can't have both. Technical debt is often a reflection of the tools of the time. So it's simply a reflection of trade-offs. So to call previous decisions based on the day's technologies technical debt, I think it's a bit weird.
Well, I mean, I think you can call it what you like. You can call it the trade-offs, but technical debt implies that, well, maybe actually technical debt is a good analogy because you take on debt because you have to, because you need the money at the time, and at some point it's got to be paid off. So maybe it's not such a bad thing at all, but people talk about it like, I often hear people talking about it like those guys were idiots.
Yeah.
They made all these mistakes.
Yeah, and of course, it's one of those, isn't it, where of course when you write the code, you understand it, but the other person, well, exactly. So what we're talking about with this thought experiment is actually we're talking about MVPs. You can either repackage your monolith to work out if there's a market. Alternatively, you can cobble something together quickly for the same goal to work out there's a market. Until we need to go quick and at scale, cloud native's off the cards, so you might as well forget about your blank slate job. Now the question then becomes, what happens if we found a market and we now need to get to scale? And of course, the question is, of course, we don't know. You might then say, okay, well, we've started with this MVP, let's go get them. That's the easiest starting point. We've put together these microservices. Alternatively, you might say, well, holy shit, we've skinned our monolith, but actually breaking this out now and strangling it using a strangler pattern to pop out microservices with APIs might actually be more expensive and time consuming and risky than starting again. But ultimately, you've learned the lessons. What does the customer want? What does the market look like? How many users have you got? So you're aiming at a clearer target. So before we think of either strangling the monolith or blank slating it, we've at least tested the market. And I think people get to that second step one step too soon.
Well, potentially, but if you don't manage expectations in the right way, you could have a disaster on your hands by being too popular, right? So if let's say you say to your board, we're gonna build this easy, what was it, car rental, easy car rental.
Actually, isn't that?
Yeah, it must be. Yeah. So we're gonna do this easy car rental thing. So we've knocked together some code, and basically under the hood, you've taken EasyJet and you've changed the word flights for cars and frigged it somehow. You do that, and then you do your advert after Coronation Street, and you find that you've got millions of people using your site, and the site falls over, and you've got a massive problem, and then it's in the papers the next day. EasyJet fails at car rentals, and then the board come to you and say, "What the hell's going on? You were supposed to." You had this product. We'd given you a little budget. to do it, and you've messed it up. And you said, no, 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 this was just an experiment to see if there was demand.
Yeah.
Then you're in real trouble because you haven't managed the expectations right. So I guess part of, I mean, maybe this is a bit of an aside, but part of the art of software engineering is managing users, the investors' expectations
Yeah.
correctly, so that they know there is a risk we're doing this, but we don't want to waste your money on something that
Yeah.
doesn't happen.
Well, it's funny because in the other book, Cloud Native Transformation, we talk a lot about this. About the first part is about experimentations, whether you're repackaging or using containers. But we visualize that as a graph with three clear steps. And when we work with companies, we will present that. We'll say, listen, this is going to be the first bit, the experimentation. We're not too worried about this point about scale and guardrails and container scanning. We're trying to work out if there's a market for this product. If there is, this is the second stage where we're going to get a minimum viable product. And in the world of web scale applications or mobile scale applications, that means secure, functional. Because what we learned earlier in the other podcast is that some of the banks that created mobile only applications, they put a piece of shit on the market and then immediately got battered in the App Store. And once you've lost your rating in the App Store, that's it. You're never coming back. And so that's the second piece. A minimum viable product. It has to have a rich feature set. It has to work. And then you've got to be smart. That's the other thing some of the sort of the larger banks were not very smart about. You've got to do subsets of users, the first 1,000, the next 1,000, then 10,000, and then scale. So we often look at that in three stages: the experimental bit, the MVP bit, and then finally the scale up when we've learned about all of our lessons.
We could learn from other industries in this because I remember I worked with a retail company, and they had this thing where they had this software rolled out, and they said, no, we're not just going to release this. We're going to do this in this way. And they would take one shop, and they would spend a month ironing out all the bugs in that one shop. And then they would take it to another shop, and then 4, then 8, then 16,
Yeah.
and then eventually roll it out across the country. They
So that
weren't
was to do with
gung-ho.
physical shops.
That was to do with physical shops, but the principle was the same.
Yeah.
You know it's not going to work for everyone at once. And the only way you're going to find out is by experimenting. So
Yeah, well, exactly. But do you know what? And this really winds me up because people say, "Well, how should we do this?" And I'm like, "Didn't you go to management school? Haven't you got an MBA? And you're speaking to a lowly Java developer as to how to incrementally roll your platforms out?" I'm like, "How thick are you? How did you get this job?" I met a retailer once. This is a really funny story. But talk about the practicalities of management. I met a retailer and they'd gone cloud native because they wanted a web scale application, that worked on Black Friday and all of that. And I said, "Well, how did you de-risk it?" And he said to me, "Well, before we launched in America, because obviously America's the biggest market, the Americans love to spend and all of that. You do not want that going wrong." He said, "Before we went to America, we opened in Finland." Then it was like, it won't matter if it goes wrong in Finland. And I was like, well, that is a pretty pragmatic way of doing it. Launch the e-store in Finland. Now, no disrespect to any Finnish people listening, but it's not the most important market. If it went wrong, a bit of bad press in Finland is not, it's not the UK, it's not Germany, it's not America, which have got massive markets. That's pretty pragmatic. And I think that's the equivalent of Netflix testing something in one state rather than all states simultaneously.
yeah, because retailers have got, even if they just did it in Maryland or, Texas or whatever, or however small, Washington, DC, um, the news would spread across America, right? So by going to Finland, they kind of contain it within that place, even if it is the same number of people.
And I do think it goes wrong when you've got executives and boards of directors who are greedy, impatient, usually both. Usually they're impatient because they're greedy and they want to see results quickly. And that never works in this stuff. As soon as you accelerate at the wrong moment, you usually accelerate into a brick wall. And I think getting managers and leaders and engineers aligned on this, that there's a bit of a three-step process: experimentation, followed by MVP, followed by the scale out. And actually, if you do the first two stages properly, the scale out becomes quick. And what I say to people is that we do the cloud like Diego Maradona played football: slow, and then quick. He only had he never had a medium speed. He used to sit around, scan, have the ball at his feet, and then he'd go. So he went from slow to quick. And now what big businesses tend to do, because they're run by men, white men with massive egos, they tend to go quickly. Oh, we're going to the cloud, blah, 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 blah. And they make quick progress because of all the pressure, and then they grind to a halt. This is the exact wrong way around. You want to go slow, and then quick.
I've got a project at home, side project that I've built over the last few years, which scrapes all the data from Rightmove, basically, from a well-known property website. And I started thinking, well, I should probably write this with it's got a Postgres database behind it, and I thought I should write this with a proper connection pool, or at least have a threaded connection to the database, which I open and close uh, uh, not too often, which is how I've been trained to manage my database connections. And actually, what I ended up doing was writing a bunch of shell scripts, which just connect to the database whenever they need to. And I've built those scripts up over time, and they're very distributed. So each script does its own job, talks to the database, and I've now got about 20 or 30 scripts that do different tasks. And I've never bothered to write it in a proper programming language because it's never been necessary to. And but if I did want to do that, it would be really easy because the logic is all nicely separated into different bits, and I would just take that shell script and turn it into a Golang binary.
What would somebody do? What if you died and I inherited this? What would I say? Would I say it was legacy junk?
Yeah, it would be. Yeah, would be, wouldn't it? That's
Yeah.
true. That's a good analogy. Yeah, because if someone else looked at it, they'd probably be, what the hell's going on here?
Yeah.
But it's easy to debug, so I don't have to recompile anything. I can just stick an echo statement in, and it shows up in the logs. It's exactly what I need.
Yeah.
If I'd engineered it to be a business, I wouldn't want to sell that as a business. If I did want to sell that as a business, I'd have to rewrite it all. But if I had to do that, it would be easy now because it was written in a way that I could do that.
Yeah, and of course this is the challenge. And when I was a lad, when I was younger, we used to say anybody could write computer code for the machine. Only great programmers can write computer code for other people. And I prided myself on that. Writing code for other people either means self-documented code, which can be done in an object-oriented language, or code with good documents, appropriate comments. But if you're moving quickly and you're innovating, your documentation is almost by definition out of date. So in a way, your code reflects the system. Now, at the end of a project, were we ever given 3 or 4 weeks to write it up, leave it to do manual? No, hell no. We rolled on to the next project.
I have seen it done, but I've never looked at how successful that documentation process was. Because usually the engineers see it as a little bit of a holiday, to be honest.
Well, I never did because I hated technical writing. I hated that. The other thing was we stopped doing it as well for another reason, is we wrote technical documentation, but it was a bit of a heuristic that nobody ever read it. And I would go to a new project and they'd say, oh, we've got this C++ library or whatever, and there's the document. Well, I just drop a breakpoint in, run it, and step through the debugger and see what it was doing.
Well, actually, that reminds me, when I was in charge of a third line support team, we used to get our support engineers would complain. They were ex-developers, so they knew how the system worked, but they'd complain that the engineers who were writing the new systems were not doing documentation, or we need more documentation. Right. And eventually I got fed up with this, and I said, no, we are writing the documentation. So we would, before a project went live, we would get the engineers to explain to us how their new system worked, and we would decide which bits were likely to break. So they'd say, I've got this great engine that does this matching thing, and we were like, yeah, that probably just works. We know you've tested the hell out of that. Yeah. But have you tested a split blame problem? And they'd be like, oh, that's probably not going to happen. And we're like, that's going to happen.
There's always the difference between developers and testers plus the people who run things. It's definitely going to happen. Oh, that won't happen. It's an edge case.
Yeah. So they're optimizing for delivery of the software that is being paid for. They're not optimizing for maintenance. And so we said we will write the documentation, and we would write, we think this bit will break and we don't know what's going to happen here, or this is how you handle that. But the point is that we would be responsible for the documentation, but they would have to give their time to us to help understand the system.
And I guess if you're building mission critical systems that are going to live for a long time, that stuff becomes very important. But I guess if you're rapidly evolving your systems and using, continuous integration modules, rebuilding your infrastructure based on Terraform scripts and all of that. I guess that's a different. I guess you don't that depth of maintenance is not quite required. That maintainability question is less important.
Well, I guess the questions change. You've got to think
Yeah,
again. What could break here?
yeah, right.
So upgrades are classic, right? The version of Terraform is out of date. That's going to happen at some point.
Yeah.
What are you going to do?
And updatability is the problem with open source. But businesses, if a new version of Kubernetes comes out or any open source tool, well, you can't just integrate that into your stack because your current setup is based on this. And of course, but it's backward compatible. Well, is it? Is it? Because the Kubernetes people say it's backwards compatible, and that could be. But there might be a peculiarity or workaround that's buried in your system. The person who buried it there has either forgotten or left or is on holiday. So backward compatibility becomes an issue. So that's why companies can never quite keep up with the open source release cycle. And it's not because they don't want to, it's because the risk versus the reward just don't match.
And also the organizational challenge of just getting a change through at all can be incredibly costly.
I don't think, people have got compliance and governance issues, right?
Well, that, and also you have to inform everyone when you're going to do a new release.
Right. So now to wrap up, Ian. So these are my big points on the blank slate. So first of all, it don't exist. Like I've changed blank slate into a verb in this podcast to blank slate it.
That's all right. You can verb nouns.
Thank you. Thank you. I'm learning that now. In Holland, they call filling your. We don't have a verb for filling your car up at the station, do we? The petrol station. You say filling the car up.
In English, yeah.
In Holland, they say I'm going tanking. Ik ga tanken. Right? Petrol tanking. Anyway, so there's no point blank slating anything in cloud native. That's to say, there's no point building a cloud native system from scratch unless you're after speed, scale, and margin. That's number one. That's the most important lesson. If you were trying to work out if there's a market out there, you can either reskin, repackage your monolith to figure out is the market there, or you can do something simple. Only then will you be confronted with the question, if the customers look like they want it and you do have to scale, then you're going to be confronted with a challenge. Do we now scale the microservice thing we did, or can we strangle this monolith? If neither of those two questions are positive, then you might have a case for building a brand new, cool cloud native system that meets the demands of those users.
But you should do it in a modular way.
But you should do it in a modular, iterative way, and therefore you won't be the team producing legacy.
Yeah.
Right? And then the third thing I wanted to say, the third point I wanted to hammer home, is there is really no such thing as pure legacy systems in the sense that they're worthless because they often generate a lot of value. And there's never a genuine blank slate either, because here's my killer line, Ian. We all live in an age, and the age lives in you. So the habits of the day, the tools of the day will be reflected in this so-called blank slate that you're about to start work on.
That sounds like it could get very philosophical very quickly. We're talking about blank slates and people and influence and
tabula rasa, wasn't it? John Locke,
tabula
wasn't that
rasa,
his thing?
Yeah. The idea that people are all born without any prejudices or prior knowledge
and John
of any
Locke
kind.
Became Skinner and the behaviorists, and Skinner said, if you give me any child, I will condition that child by torturing it to anything. I can create a computer programmer, a priest, a teacher. Skinner has been proven to be incorrect. So on that happy note, Skinner, we will return to Skinner in about 25 episodes from now. He's on the list. He appears in about 1960, but that's a different story. So that's been the Cloud Native Attitude, episode 6, the Mythical Blank Slate. He's been Ian Mile. Say goodbye, Ian.
Goodbye, Ian.
I've been Jamie. Goodbye, Jamie. And for those listening, you can get excited because the next time we meet, we're going to be talking about continuous delivery and what that means in the world of cloud native. Until then, goodbye.
Goodbye.